I'm a student from Pamantasan ng Luzon ng Maynila, taking Bachelor of Science in Electrical Engineering, Adrian Leonardo. We'll discuss counting sample points, the basic counting principle, multiplication rule. If a certain experiment can be performed in n sub 1 ways, and corresponding to each of these ways, another experiment can be performed in n sub 2 ways. Then, the combined experiment can be performed in n sub 1 times n sub 2 ways. Some examples of this topic. Example is this, example 2.3. Suppose a coin and a die is tossed. Find how many outcomes there are in the sample space. Outcome on coin is head and tail. And outcome on die is 1, 2, 3, 4, 5, 6. In head, there are 1, 2, 3, 4, 5, 6. And in tails, it has 1, 2, 3, 4, 5, 6. So it has H1, H2, H3, H4, H5, and H6. And in tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Hence, by means of these diagrams, there are 12 outcomes. Applying the basic principle, there are 2 times 6 equals to 12 outcomes. If repetition of digit is not allowed, how many 3-digit numbers can be formed from the digits 1, 2, 4, 5, and 6? And how many of these are odd? So a 3-digit number is composed of hundreds, tens, and unit digit. Hence, by multiplication rule, there are 5 digits, 1, 2, 4, 5, and 6. So 5 times, when we pick 1, there are 4 digits left, so 4. And we pick 2, after we pick 2, there are 3-digit numbers left, so 3. And the answer there is 3-digit numbers. And in odd numbers, for odd numbers, there are 2 odd numbers, which is 1 and 5. So we pick. So there are 2 times. After that, we pick one of these 2. So if we pick 5, there are 4-digit numbers left. So 4 times, and then if we pick 2, then there are 3 digits number left, so 3. And the answer is 24 3-digit odd numbers.
I'm Julius Lagrata from the Pamantasan of Luzon ng Maynila, taking up the Bachelor of Science in Electrical Engineering. Today, I will tell you how to get the permutation, which is the term permutation refers to the arrangement of all part of the set objects. Some useful permutation techniques involve the following. First is the factorial, second is the permutation. And the factorial, it is all the elements to be arranged in a certain order of the number can be obtained by a simple multiplication rule. In the permutation, it is the example to be considered that the case that only a part of the whole is to be arranged in order. We have the branch first of factorial, and the factorial is element to be arranged in a certain order. The number of permutation can be solved by a simple multiplication rule. First example of this is the letters A, B, and C. Letters A, B, and C can be arranged from ABC, BCA, ACB, CAB, BAC, and CBA. So, 3. The number of permutation of an object could be considered as n factorial. Or in a long method, it can be 3 multiplied by 2 and multiplied by 1. So we have 6 ways. Can we consider the letter A, B, C and this arrangement? Example, for the factorial is in the letter A. In how many ways can the 3 boys and 3 girls sit in a row? In letter B, in how many ways if the boys must sit together? And the answer for letter A is, since we have 6 persons, can be arranged or to be seated in a row. So we only have 6 factorial. Or in a calculator, we only to input 6 times 5 times 4 times 3 times 2 and times 1 and equal to 720 ways. And for the letter B, the group of boys will be considered only as a one group and girls will be arranged separately. So here, we only group the boys in B1 and another one is G1 for the first girl, G2 for the second girl, and G3 for the third girl. So overall, we have 4 factorial or we have 24 ways them to be arranged in a one group. Or the second branch of the permutation is the letter B, the permutation. Permutation will be defined as the part of a whole is to be arranged in order. Consider the letter A, B, and C. In the number of permutation of n objects taken at R, the time is n factorial over the quantity n minus R factorial, or can be simplified as P multiplied by NR or N permutation R. So, in example, letters A, B, and C can be arranged in AB, AC, BC, BA, CA, and CB. So, we have N or the 3 and permutation 2 is equal to, according to scientific calculator, 3 permutation 2 is equal to 6, or we have 6 ways. Or in the long method, we have, cut mo nga muna. We have to input in our scientific calculator the n or the 3 factorial over 3 minus 2 quantity factorial should be equal to 3 factorial 3 minus 2 quantity factorial be equal to 6 ways. We have the same answer using the short method and the long method.
Hello everyone, I'm Charwin Balajadia from BSEE. In addition, for the topic permutation, number 1, circular permutation. Suppose the letters A, B, and C is to be arranged in a circular way. The starting point of the circle can arbitrarily chosen to be fixed. Number 2, permutation with repetition. Permutation with repetition. Consider the case when the objects to be arranged are not all distinct. Suppose the letters A, and B are to be arranged. I'm here to give example in circular permutation. The formula for circular permutation is n minus 1 factorial. Example problem, if 4 Americans, 3 Chinese, and 3 Filipinos are to be seated in a round table, how many seating arrangements are possible when people of the same nationality must sit next to each other? Solution, supposed to be this is the table that they are sitting. American, Filipino, and Chinese. We need to solve first the ways that they are arranged. 3 minus 1 factorial equals 2 ways. For American, they are 24. So 4 factorial equals 24. For Chinese, 3 factorial equals 6. And for Filipinos, 3 factorial is equal to 6. Altogether, 2 factorial plus times 4 factorial times 3 factorial times 3 factorial equals to 1728 with repetition. Permutation with repetition can be solved by this formula. N factorial all over n sub 1 factorial, n sub 2 factorial until n sub k factorial. Example problem, in how many ways can the letters of the word probability be arranged? Solution. First, get the tally of the repeating letters. P equals to 1, R equals to 1, O equals to 1, B equals to 2, A equals to 1, I equals to 2, L equals to 1, D equals to 1, and Y equals to 1. There are 2 letters that are repeating. So, from the formula, substitute the given numbers. N factorial, 9 factorial, total letters of the probability all over 2 factorial because of the 2 letters that are repeating, and there are 90,720 ways.
I will discuss about combination. The combination of n objects taken r at a time is a selection of r objects out of n where order does not count. It is denoted by any of the symbols and given by this formula. Good day everybody. Today I will be giving example for combination. Example is, a school wants to buy 6 chairs for its classroom from a local supplier. The supplier has 10 chairs in stock, 4 of which are foreign made. Question: find how many ways there are to buy 6 chairs from the supplier. We can see that our total number of chairs is 10. And the school wants to buy 6. So our R will be 6. Applying the formula for combination, we use n factorial all over r factorial quantity n minus r factorial. We substitute n and r n factorial all over 6 factorial quantity 10 minus 6 factorial. We get
Titignan mo lang yung reaction.
we get 210 ways, which means there are 210 ways that they can buy 6 chairs from the supplier. Rn is 6 and Rr is 4 because there are 6 available chairs in a local supplier and 4 of which are foreign made. So our solution is 6C4. Multiplying it to the given for which this school prepares 4 local and 2 for foreign made chairs. So 4 combination 2. If we use the long method, we must substitute it in the formula. 6 factorial all over 4 factorial 6 minus 4 factorial multiplied by 4 factorial all over 2 factorial 4 minus 2 factorial. This equals to 90 ways. So there are 90 ways that they're to buy chairs if the school prepares 4 local and 2 foreign made chairs.
I am Gabriel Lapinig from Pamantasan ng Lungsod ng Maynila, studying Bachelor of Science in Electrical Engineering. And today, we will be discussing about probability of an event. So, in probability of an event, we study the chances or the percentage of an event that will happen. Let's talk about probability of an event. Probability of an event is denoted by the probabilities assigned to the simple events that comprise the event A. Event A, note that S is the sample space. Here are some terms about probability. And here are some terms about probability. Probability can be less than or equal to 1 and also greater than or equal to 0. B. Probability of S is equals to 1. C. If A and B are mutually exclusive events, then probability of A sub 1 union A sub 2 union ... until A sub n is equals to probability of A sub 1 plus probability of A sub 2 plus probability of A sub n. And here is the example for probability of an event. Suppose a sample space S consists of 4 elements. S equals to A sub 1, A sub 2, A sub 3, and A sub 4. Find probability of A sub 1 if probability of A sub 2 is equals to 1/3, probability of A sub 3 is equals to 1/6, and probability of A sub 4 equals to 1/9. According to the principle, probability of A sub 1 plus probability of A sub 2 plus probability of A sub 3 plus probability of A sub 4 is equals to 1. Substitute the values. There. Then, according to my scientific calculator, this theory 11 so we just subtract this from 1 and we will get probability of A sub 1. Which is equals to 7/80. Example for probability of an event. A card is drawn at random from a standard deck of cards. Find the probability that the card drawn is a black card, a face card, a black card, or a face card. Remember the formula. N of A over N of S, which A denotes the event and S denotes the sample space. So getting the black card, the probability of getting a black card. In a standard deck of cards, there are 26 black cards. So our event A is equals to 26. And our sample space, which is the standard deck of cards, is equals to 52. B. Getting a face card. In a standard deck of cards, there are 12 face cards. So, 12 will be our event. And again, the standard deck of cards is our sample space, which is 52. C. Since this is not an exclusive event, to get the black card or a face card, we need to get the intersection, which is 26/52 multiplied by 12/52. 26/52 multiplied by 12/52 is equals to 3/26. So, our equation will be probability of A sub 1 union A sub 2 is equals to probability of A sub 1 plus probability of A sub 2 minus the intersection, which is 3 over 26. Substitute the values. 26 over 52 plus 12 over 52 minus 3 over 26. 26 over 52 plus 12 over 52 minus 3 over 26 is equals to 8 over 30.
Thank you, Mr. Ando. I love you anytime. You make me happy and give me peace. 今夜は君の胸で眠りたい。すげえ儚くせえけど母なる森